Hi everybody. Today we are going to start on finding volume of solids, but this time the cross sections are going to be perpendicular to the y-axis. Last time they were perpendicular to x, this time they're perpendicular to the y. So instead of our cross sections going this way, they'll be going horizontally. They'll be going this way. Okay? So, excuse me. So in order to do that, we're going to need to follow a few steps. This time, since our cross sections are going to be perpendicular to the y-axis, we will need to integrate with respect to y. And in order to do that, we're going to need to change up our functions. So the first thing we're going to need to do is rewrite our equations in terms of y. And what I like to do when I do this is I like to use Desmos to check to make sure that the new equation that I wrote is the same as the old equation. After we do that, we are going to find a formula for the area of our cross section, just like we did last class. And then finally, once we figure all that, we'll be able to substitute that into our integral, integrate the formula for the area of the cross section with respect to y. Subtle difference here though, this time instead of the lower and upper limits being x values, now they are y values. So the y1 will be our lowest y value in the region, and y2 will be the highest y value as we're working on these. So let's start with our first example. This time we have the base of a solid region is enclosed by the semicircle that they've graphed for us here, and cross sections are going to be perpendicular to the y-axis. So they're going to go this way. If you think back to the pop-up notes we did the other day, this is where your line would go, and then in 3D, the semicircle would come up. Whoa, that's a really bad semicircle. The semicircle would come up off the piece of paper like this, and there would be several of them, and they would form a solid. Okay, but let's go back. I'm getting ahead of myself. Let's go to step one. Step one is going to be to rewrite my equation in terms of y. So I'm going to take my original equation here, and I'm going to solve it for x. So here's the equation. Y equals the square root 49 minus x squared. I'm going to try to solve it for x. So that means I'm going to square both sides. Y squared equals 49 minus x squared. Then let's see, what do I need to do next? Looks like I need to subtract the 49 on both sides. Y squared minus 49 equals negative x squared. Got to get rid of that negative in front of the square root, so I'm going to divide everything by negative 1. Negative y squared plus 49 equals x squared. And then to get the x by itself, I will need to take the square root of both sides. And when I do that, I need to remember that I'm going to have to include a plus or minus. So I have plus or minus square root of negative y squared plus 49 equals x. Now, once I get that, I like to use Desmos to verify that I've done that correctly, which means I'm going to graph the equation that I came up with and the original equation to see if they end up being this picture. Because I want to make sure I didn't make a mistake there. If I make a mistake here, then there's no chance the rest of my problem is going to be correct. So let me pull up a Desmos calculator. We are going to, there we go. Actually, I want you over here, and I want Desmos over there. We're going to zoom out. There we go. Okay, so the original equation was y equals the square root of 49 minus x squared. Okay, semicircle. This is the one the problem gave me, which is absolutely what I see right here. Great. Okay, now I'm going to type in this stuff, the stuff that I came up with, to see if it does in fact graph the same shape. So let's type in x equals square root of negative y squared, not y2.
Good afternoon, General.
So here's the original. Now when I go to graph mine, I see part of an entire circle and the other part. So the positive square root forms the right side, which makes sense because that's the two quadrants where the x values and the whole coordinate plane are positive. And then the negative x parts. Now I did graph an entire circle, and I'm only interested in integrating this top part, and that's okay as long as I use the correct limits on my integrals. But all I want to make sure is, here's the original. Are these equations going to give me the same lines? And it looks like they do. All right, so now let's look at how we're going to set this up. So I have my cross section. Remember, the cross sections are going to go perpendicular to the y-axis, and they're going to come up vertically off, okay? So my cross section looks like this. And the area of this cross section is half a circle, so 1/2 pi times the radius squared. So to come up with the formula for the area of the cross section, I need to know a formula for the radius. Well, from here to here is x, or a positive x. The positive x, I have an equation for x right here. And I want to use the positive one because it's actually more convenient. But I'm going to square it anyway, so it really doesn't matter. But so I'm going to use that x equals the square root of negative y squared plus 49. So this radius is the square root negative y squared plus 49. So when I go to find a formula for the cross section, area is 1/2 times pi times that radius, negative y squared plus 49 squared. So when I square that square root, it will be 1/2 pi. And then when you square a square root, it kind of just goes away. So we have negative y squared plus 49. So I've done step 2, which is find the formula for the area of each cross section. Now that we've done that, we can find the volume. That will be the integral from the lowest y value of the region. So the lowest y value goes from right here, which is y equals 0, to the highest y point, which is 7, of this entire formula. 1/2 pi times negative y squared plus 49. And then I want to do all of that with respect to y. And now's the time that we go when we type all of that in to Desmos to get our final answer. So it looks like it would be approximately 359.18, and if I rounded 3 decimal places, 0.189. All right, let's try another one. Looking at the second one, this time the base of the region is enclosed by this. Here is the equation. And cross sections this time are going to be perpendicular to the y-axis. Ooh, they're going to be equilateral triangles this time. So let's see what happens. I'm going to start off first by taking this, and I'm going to solve it for x. So I've got y equals negative x squared over 4 plus 4. Subtract the 4 on both sides. Y minus 4 equals negative x squared over 4. Then I'm going to multiply both sides because I want to get rid of that 4 and the negative at the same time. So let's multiply both sides by negative 4. So I get negative 4y plus 16. And over here, the negative and the 4 cancel, equals x squared. Then when I solve for x, I'll need to take the square root again. And don't forget you need plus or minus square root, negative 4y plus 16. And again, I want to get Desmos up and verify that the equation that I came up with actually does match. So let's see. Close out the other problem. Type in the original. So there's the original. Here's mine. X equals oh look, they match. See how they match nicely? That's what we want to happen. And then if I were to do the negative side, let's just copy and paste. Negative. Oh, look, there's the other side. Oh, good. So I solved this for x correctly because my equations match that one. All right, next, I want to come up with a formula for the area of the cross section. So this time, let's see, my cross sections are equilateral triangles. And so if I tried to imagine what that would look like, that would be the bottom and it would go across. So I've got an x from the y-axis to the curve and then another x here because I've got the positive x and then the negative x. So that's 2 x values, which means that this whole base is 2x. Or I could think of it in terms of y as 2 times the square root of negative 4y plus 16. And this is what I'm going to use when I go to find my area. Now remember that the formula for the area of an equilateral triangle is square root of 3 over 4 times the side squared. So when I plug in that length for the side, it's the square root of 3 over 4 times 2 square root negative 4y plus 16 squared. And when I square that part, the 2 gets squared and the square root goes away. So my formula for area is square root of 3 over 4 times 4 times negative 4y plus 16. And then it also looks like this 4 can cancel out with that 4. So my area is going to be the square root of 3 times negative 4y plus 16. So when I go to finally find the volume, I have my definite integral. My lowest y value down here is 0. The highest y value is 4. Then I'm going to plug in that area formula. 3 times negative 4y plus 16 dy. I will type this in and I will find my final answer. Scoot over. And then B, and if you want to, just for safety, put parentheses around the whole thing, 55.426 is the volume of my region form. So give these problems a try. If you have any questions, let me know, and I'll be here to help you. Have a great day.